Today's lecture is on Chapter 8, Respondent Conditioning. Now this is a new type of conditioning. We've already talked about instrumental or operant conditioning, but this time we're going to go into respondent conditioning, which you might have already heard called Pavlovian conditioning or classical conditioning. As you find with a lot of the learning literature, people like to use multiple different names for the same basic idea. So if you've heard of either classical or Pavlovian conditioning in earlier classes, same thing here. We just call it respondent conditioning this time around because that's what most closely matches the behavior modification literature. So step one is to look at the difference between operant and respondent conditioning. So how does this new topic that we're looking at today, our respondent conditioning, how does that differ from what we've talked about to this point so far when we've been talking about operant behaviors? So operant behaviors are thought of as controlled by their consequences. So the consequence of a particular behavior is what drives that behavior to either increase or decrease. The consequences determine that. For respondent behaviors, we're instead looking at the behavior being controlled by antecedent stimuli. So whereas for the operant behaviors, we talked about them being controlled by the outcomes or the consequences, now the sort of pre-existing stimuli in the environment are what are going to be eliciting that behavior. And we had previously seen a similar term. Instead of eliciting, we had talked about evoking behavior. We use that term evoking when we talk about stimulus control, where our antecedent stimuli in those situations are allowing those behaviors to occur. Here, antecedent stimuli are controlling the behaviors, they're eliciting the behaviors more directly. Whereas with our stimulus control, we were more looking at creating an environment in which those behaviors could happen. So terminology is going to give you some key points to decide if we're talking about respondent behaviors or operant behaviors or stimulus control. There's certain words that are linked with each. Okay, so that's the behaviors themselves. We want to talk about the process of operant conditioning. Operant conditioning involves manipulating those consequences that control the operant behaviors. For respondent conditioning, we're going to be manipulating our antecedent stimuli to change the behaviors that are being controlled by those stimuli. Now, of course, you can't talk about Pavlovian conditioning without mentioning Pavlov. So I'm going to do the customary acknowledging of Pavlov, but there's also a link here if you want a more in-depth refresher on Pavlov and his research. I just find that by this point you've gone over it a bunch of times in a couple of different classes, so you already know this. But Pavlov was originally a physiologist and wasn't actually trying to study learning or even psychology. He was trying to study digestion. In their lab, they were collecting saliva and other digestive secretions from dogs in order to do research and to sell to make money on the side to help fund their lab. So that's what we have here in the image, is just a dog with a cannula that would be collecting saliva. And as part of that research, they happened to notice that dogs would begin to salivate just at the sight of food. They didn't have to be able to smell it or they didn't have to start eating it. Just the sight, knowing that they were going to be getting food, made them salivate. And so they called these anticipatory stomach secretions, or sometimes they called them psychic secretions, because it seemed to be sort of this foreknowledge of something that was coming. And at the time, nobody really cared about these psychic secretions until Pavlov decided to use the whole setup, this salivary secretions and measuring quantities. He decided to use it to study associative learning and our nervous system. So by marketing it in a different way, all of a sudden people started caring. So this accidental discovery is what has led us to the more complex view of classical conditioning or Pavlovian conditioning or respondent conditioning that we have today. So let's start by looking at the standard classical conditioning paradigm. And again, this should be review for all of you having taken Psych 104. So we're going to go over this fairly quickly. The textbook has more detail if you need it. But yeah, so the basic idea is that you have some kind of unconditioned stimulus, shortened to a US, which is going to be some kind of environmental trigger, something in our environment. So for Pavlov, they might use dog food or meat. And that unconditioned stimulus is something that an animal doesn't have to learn anything about. It's usually going to be biologically relevant, something that they are automatically going to have a response to, which brings us to our unconditioned response, shortened to UR. This UR happens in response to our unconditioned stimulus. So if our unconditioned stimulus was meat, our unconditioned response would be salivation. And the important part here is that there is no need for prior training. This is something biologically relevant. It's just going to happen. You don't have to train a dog to salivate when they get food. I will note here that I use the terms US and UR. Some other texts and some other papers will use UCS and UCR for unconditioned response. So if you ever see that when you're looking through different sources, it means the exact same thing. But half the literature seems to use one version and half the other. So just so you're not put off by that. All right, so that's our setup before we start conditioning. The next thing that's important is our neutral stimulus. So this is still before conditioning, before we do anything at all. We don't have to train the dogs anything about our unconditioned stimulus or response. We also need to have a neutral stimulus. So this could be shortened to NS. Sometimes we're just going to call it a neutral stimulus because it doesn't stay a neutral stimulus for long. So this neutral stimulus originally or initially is going to elicit no response. So this is something that an animal doesn't know anything about and therefore doesn't respond to in any significant way. So you can have a metronome or a light or a tone or whatever, and the dog's not going to do anything when it sees or hears or feels that stimulus because it doesn't mean anything. It's neutral. This neutral stimulus will become a conditioned stimulus, our CS, which is going to be a stimulus that precedes or that signals the upcoming presentation of our unconditional stimulus once we start our conditioning. So let's look at that happening. During the conditioning process, so once we actually start that acquisition of learning here, we're going to pair our neutral stimulus and our unconditioned stimulus, and we're going to present them together. So you can talk about presentation together, you can talk about pairing them, both mean the same thing, and the result at the time is that this combination of neutral stimulus and unconditioned stimulus is going to yield our unconditioned response. So we can have a sound, a tone, and food, and it's going to lead to salivation. Now, the salivation is still an unconditioned response because it's mostly being driven by our unconditioned stimulus. And that kind of makes sense because the tone still doesn't really mean anything to the dog. Now, for this to take effect, you're usually going to have multiple pairings, multiple trials, where you pair this neutral stimulus and the unconditioned stimulus over and over and over again, so that there is an association formed. And then that leads us to, after conditioning has occurred, after you have done multiple repetitions, multiple trials, our neutral stimulus is now going to be considered a conditioned stimulus because we have conditioned that stimulus. It has now sort of acquired some kind of meaning, and that conditioned stimulus, when it is presented, even in the absence of our unconditioned stimulus, even without food being presented, we are going to now get a conditioned response, or CR. And so our CR is going to be a response that comes to be elicited from our CS. So here we have our CS, which is our tone, and the dog is salivating. Now, are you R and our CR are both the same action. They're both the same response here. In both cases, the dog is salivating. But in earlier situations, this would be considered a UR, an unconditioned response, because it was being driven or caused by our unconditioned stimulus. The dog was salivating because there was food. But later on, the dog is still salivating, but this time the reason they're salivating is different. They're salivating because of the tone. They're salivating because of our conditioned stimulus, and so we now call it a conditioned response, even though it's still the same behavior. Okay, so that's the review part, hopefully. We have a couple more basic definitions, some terms that you will want to know. So when we talk about respondent conditioning, we're talking about the process that you're going through, the process of establishing a conditional probability between a CS and a US. Basically, when we talk about respondent conditioning, we're talking about that process of pairing our CS and our US to have that acquisition occur. If we talk about a respondent or the respondent, we're talking about the specific response that's being elicited by our conditioned stimulus. So a respondent is another way of saying our conditional response, or our CR. Now, if we want to try and measure that respondent, if we want to look at our CR, there's a couple of different ways that we can do this. The textbook doesn't state these explicitly, but we do end up seeing a lot of these in examples, so I figured it'd be a good point to just talk about them. So we can measure our respondent, we can measure our CR by looking at its latency, by actually running test or probe trials, or by specifically looking at the intensity of it. So for the first of these, if we're looking at our latency of our CR, we're looking at the interval of time between the conditioned stimulus presentation and the conditioned response. Basically, how long does it take for us to see that conditioned response after we've presented the conditioned stimulus? Now, if we're going to be looking at this measure, we have to be able to do that before our unconditioned stimulus is presented. So if this was happening during acquisition or during training, then we would have our conditioned stimulus and our unconditioned stimulus happening early, and then we would want to hopefully have our conditioned response occurring before the unconditioned stimulus was happening. Just grabbed my little pen tool here. So instead of what we had talked about, which was sort of in training, we'd have CS plus US assumedly at the same time would lead to some kind of response, whether that's a CR or a UR, whatever. Instead of those happening at the exact same time, for this to be happening, to measure that latency, we'd have to have our CS, and then we'd have to have a gap, and then we'd have to have the US. And then hopefully somewhere in here, once the organism had learned that this CS is related to that US, clean that up, we would have our response show up somewhere in the middle here. So if that was our timing on an axis here, we would have the response occur quickly. So if we use the dog example, where dogs learned that when they saw food, they would soon be given food. So our CS would be seeing the food, and our US would be when they are given the food. They would start salivating before they were given the food, but after they saw it. So we could measure latency there by looking at the difference in time from when they see the food to when they start salivating. So kind of a roundabout way to get to that, but that's what we need to keep in mind if we're measuring latency. One of the more common things that we will see is to use test or probe trials. And this would be basically once you've hopefully established that association, you can present your CS alone, which is basically what was done here. This would be considered a probe trial because we have our conditioned stimulus alone, just the tone. The dog in that case didn't get an unconditioned stimulus. They didn't get any food, so that could be considered a probe trial. We can also measure the intensity of our CR, basically using the idea that our CRs will get stronger or have a larger intensity as that association is learned. So at the very beginning, when our conditioned stimulus is still effectively a neutral stimulus, we should see very little responding to that conditioned stimulus. But as that association is learned, the intensity will get higher and higher, and our CR will basically get larger. So these are just some things that we might see as we look at different examples measuring respondent conditioning, and specifically the respondent part of that process. All right. Before we move on, just one more time, telling the difference between our two classes of learned behavior, respondent versus operant. So if we look at our function, we've already kind of did this, where respondent conditioning, the behavior is elicited by a stimulus. Operant, the behavior is evoked to produce or remove a stimulus. So it's motivated by the outcome or by the consequence. Our controlling event for respondent, the stimuli preceding the response control that response. And for operant, the stimuli following the response, or our outcome, is what controls that event. The reason why I'm going over this so many times is because it's really easy to confuse them, and you will absolutely be asked questions on the exams where you'll have to tell the difference between the two. All right, so moving on, slightly different images, but same basic ideas. We've talked about first order conditioning. We didn't call it first order conditioning. We just called it conditioning so far, respondent conditioning or classical conditioning or Pavlovian conditioning. But we've only kind of looked at our conditioned stimulus and our conditioned response and how we learn those things. So same basic setup here. Our originally neutral stimulus that becomes our conditioned stimulus. We have our unconditioned stimulus that elicits that unconditioned response, and there's that weird notation with an extra letter in it. During the conditioning, we have the pairing of our conditioned stimulus and the unconditioned stimulus, and then afterwards our conditioned stimulus elicits a conditioned response. Cool. First order conditioning, because we're only having sort of one round of conditioning. What we do see next is that we can have what's called higher order conditioning. Most of the examples that you'll see will just add like one extra step. So it could also be called second order conditioning. You can have multiple levels of conditioning. You can have third order conditioning, fourth, whatever. But the more extra steps you add, the less strong your associations become. So as you get more and more removed from your original unconditioned stimulus, the worse the association becomes. But let's look at our example of higher order conditioning here, of specifically second order conditioning. So in order to have this second order conditioning, we actually need to start with first order conditioning. So the first step is training our conditioned stimulus, our tone, to elicit a conditioned response. So when the dog hears this tone, they're going to salivate. That was step one. Step two is to go through the conditioning procedure again, but this time we're going to be pairing a neutral stimulus with a previously conditioned stimulus. So in this case, our second neutral stimulus is going to be a black square. And before we do any training, a black square doesn't mean anything to a dog. So no salivation, no response, cool. During that higher order conditioning, during this acquisition stage, we're going to pair our neutral black square with our previously conditioned stimulus of a tone. So here we note this CS as CS1 because it was our first order conditioning. It was basically step one. So we're pairing our black square with our conditioned stimulus, And this should elicit our conditioned response because we had already trained our CS1, our tone, to elicit that conditioned response. Now, after higher order conditioning has occurred, after we've done multiple pairings of this black square will also come to elicit a conditioned response. So our black square, which was previously neutral, becomes CS2, which is a second order conditioned stimulus. And it's going to elicit that same conditioned response. Okay, so now that we understand the basic procedure and an extension of that basic procedure, let's talk about the actual pairing of our CS and our US. There are 4 or 5 different common procedures that tend to be talked about in various textbooks. The image that I have here is the one that I use for most of my classes. It's a little bit different than what we tend to see in the textbook here. The main difference here is that we have short delayed conditioning and long delayed conditioning, which our textbook for this course just condenses down into one term, which is delayed conditioning. But I'll talk about those on our next slide here. So our short delay conditioning is basically saying that our conditioned stimulus is presented alone, but our unconditioned stimulus overlaps shortly after the onset of the conditioned stimulus. So let's look at a visual of that. And for each of these, we have kind of a little diagram down here where if you think of this as a graph, this would be our x-axis for time. So as we move along, it's like time is passing. And then our y-axis is kind of a dichotomy of on versus off. So if we're reading this, we look at the first line, and this is for our conditioned stimulus. So this would be for our tone. So as time goes on, the line is low, so it's off. So there's no tone, there's no tone, there's no tone. And then we hit this point in time, and the tone turns on. And it stays on for this length of time, and then the tone turns off and stays off for the remainder of the trial. We then can look at our unconditioned stimulus, and it's off, it's off, it's off, it's off, it's off, and then it's on briefly, and then it's off again. And so these diagrams are just really helpful for telling us when the two stimuli are on or off relative to one another. So this is the visual representation of our conditioned stimulus starts, and it starts by itself, but after it starts, while it's still going, our unconditioned stimulus starts as well. So this would be like we hear a tone, and the tone plays for 30 seconds. But after it's been playing for 15 seconds, the dog receives food. And that unconditioned stimulus of food sticks around for 30 seconds, so even after the tone stops, there's still food for a little while. Now, this type of conditioning is usually one of the most effective conditioning procedures, and it is more effective when this distance from the start of our conditioned stimulus to the start of our unconditioned stimulus is very short. Usually less than a second is going to be the most beneficial. And this kind of conditioning is one of the most common that we'll see out in the real world. So this matches a lot of what we would encounter out in the wild. As an extension of this, we can look at long delay conditioning, and all that does is basically says that our conditioned stimulus starts much earlier, and there's a much longer delay between the start of our conditioned stimulus and the start of our unconditioned stimulus. So they're still the exact same setup, just this conditioned stimulus is on for a lot longer. So this would be like the tone starts playing and it plays for 10 minutes before the dog gets food. And as you might imagine, because this is a longer delay between the start of this and the start of this, it's not quite as effective. So those are both types of delay conditioning. We can just play with the distance between the start of our conditioned stimulus and the start of our unconditioned stimulus, and it changes our effectiveness of the procedure. All right, the rest of these are going to match a little bit more right off the bat from what's in the textbook. Next is trace conditioning. In this situation, there is no overlap between our conditioned stimulus and our unconditioned stimulus. So we have our conditioned stimulus turns on, runs for a certain amount of time, and then turns off before our unconditioned stimulus turns on for the first time. So there's no overlap here. The conditioned stimulus is on and then it's off, and then our unconditioned stimulus is on and then it's off. For this setup, again, our timing matters, and the longer the gap between our CS and our US, we're going to see weaker learning and weaker responding, though that can depend on which response is being conditioned. This is another one that's fairly common in the real world, where they don't necessarily have to overlap, but it's not quite as effective as our delay conditioning setup. All right, next we have simultaneous conditioning, and this is one of the easier ones to remember. Basically, our CS and our US both turn on and turn off at the exact same time. So the onset is the same, the offset or the turning off is the same, and they run for the same duration. These are quite a bit less common out in the real world, and they're much less effective than either of the delayed or trace conditioning procedures, mostly because the CS isn't really telling us anything new that the US isn't telling us. The tone being present while the dog has food doesn't really let the dog learn much about the tone because they've got the food to pay attention to, so the tone doesn't really matter. Our next one is backward conditioning, and this is the least effective of all of the options. And in this case, it kind of is what it sounds. It's backwards. Our unconditioned stimulus happens first, and then the conditioned stimulus happens. Now, this is a weird setup because it's like you give the dog food and then wait a while and then play the tone. So the results here are inconsistent because it's really hard to associate this neutral stimulus at the beginning with something that happened in the past. That's not usually how learning works in the real world, so it's a lot harder for these kinds of associations to be learned. It can be effective. You can see it set up in the lab when everything's really controlled, and there's some logic behind it working. Say if you were a prey animal and you were attacked by a predator, you would have the unconditioned stimulus of the pain of getting attacked by a predator before you ever realized the predator was there. But if you manage to survive an attack and remember what you saw after you escaped, that might help you learn something in the future. So we can come up with stories that make backward conditioning work. It's just not as effective and kind of hard to see in the real world. All right, our next topic is respondent extinction, and this is kind of an extension of having talked about extinction already. So just like operant extinction, respondent extinction is going to be the presentation of the thing of interest in the absence of what it's associated with. So here, our respondent extinction is the presentation of our conditioned stimulus without the unconditioned stimulus. Now this extinction can only happen after acquisition has occurred. So if our CS isn't actually a CS yet, if it's still a neutral stimulus, then it can't be extinction because when it's a neutral stimulus, there's no responding to begin with. So you can't have a reduction in responding when there's no responding to begin with. So the idea would be that with this respondent extinction, there should be sort of a base level of responding that tends to happen. So you sit at a fairly high level of responding. And as you have the exposure to that CS without getting the US afterwards, you'll see a drop off in response. And as you might expect, when we talk about extinction, we can also talk about spontaneous recovery, same as what we have already spoken about for operant behaviors as well. So spontaneous recovery of our conditioned response can occur after a particular time has elapsed. So you may remember our diagrams that look something like this. So we would have an acquisition curve. So this would be our acquisition. Our y-axis would be responding of some kind, and then our x-axis is time. So we have acquisition, and then we hit a particular period of time. We put in our phase line, and we move over to extinction. So here we would be presenting our conditioned stimulus without the unconditioned stimulus. So our dog hears the tone but doesn't get food afterward. So they learn that they might hear the tone, but they no longer get food after they hear the tone. So their salivation would start dropping off because they're not getting the food that they had come to expect after hearing that tone. So this is our extinction phase where we drop off like this. Then if we have a break, maybe we've ended our trials for the day and we come back the next day, we can see a small uptick in responding. So we would see a little bit of salivation here because there was a gap. So a span of time has elapsed. So we see spontaneous recovery. And if this is still being presented in extinction, if they are still hearing the tone but not getting food, then our salivation is going to drop off dramatically. And again, if we have another break in time, it's going to drop off again and again and again, much more quickly each time. And each of these spontaneous recovery pieces or peaks is going to be lower than what was originally seen in terms of responding during acquisition phase. So each of them is going to be a little bit less each time. We also see this really neat phenomena where the reacquisition of an extinguished conditioned response will occur quicker than during initial training. Basically, if you've already learned an association, if your dog already knows that when they hear a tone, they get food, even if you've extinguished that particular association, if you then play a tone and give them food again, they'll relearn that association much, much faster than they did the first time around. So once you've learned something, it's a lot easier to relearn it. All right. Now, the last couple of slides are all, I believe, about different variables that affect our respondent conditioning. So what things should we keep in mind that can affect respondent conditioning? I think I said that backwards the first time around. But the first of these variables that we want to look at are our CSUS contingency. Basically, how closely associated is our CS and our US. So we're going to look at an example to help illustrate this point. So this is research from Rescorla back in the 60s. And so this would be looking at behavior in rats, where we have our conditioned stimulus is a tone, our unconditioned stimulus would be a shock, and then our conditioned response is the suppression of lever pressing for food. So our unconditioned response, which we don't specifically mention here, would be a suppression of behavior. So suppression of lever pressing would absolutely count as an unconditioned response because the response to shock is to freeze. Now, this is a little bit of a weird graph here. So this is giving us a bunch of information. At the top it says P of US and CS is 0.4. And this is basically telling us that the probability of the tone and the shock co-occurring is about 40%. So about 40% of the time when you hear the tone, you also get a shock. What these points along the side here, the 0, 0.1, 0.2, and 0.4 are giving us, that's the probability of the shock occurring on its own. So this one is telling us if you hear a tone, this is how likely you are to also get a shock. And these numbers are telling us how likely you are to get a shock on its own. So let's start with the easiest one here. So at a 0, you are completely unlikely, 0% chance of experiencing a shock without hearing a tone first. So if you hear a tone, you have a 40% chance of getting a shock, and if there is no tone, then you will never get a shock. And so what we see is that as time goes on, the rat learns that when they hear a tone, it's likely to be followed by a shock, and we see more and more suppression. Basically, they're doing less and less lever pressing. So we're seeing more of our conditioned response. They're learning that acquisition. And I'm just noticing here that this is labeled as days of extinction. That should actually be training. A-I-N-I-N. Yeah, that's really, yeah, that's totally legible. I think that's just a weird carryover of an axis from a different graph that shouldn't be there. All right, so that's corrected there. If we wanted to look at, let's skip all the way up to our point 4. So at the top here, we're saying that we still have that probability of, if you hear a tone, there's a 40% chance of getting shocked immediately afterwards. But the probability of getting shocked on its own is 40% as well. So you're just as likely to get a shock when you hear the tone as when there's no tone at all. So the tone isn't really telling us any useful information, and so we actually see no adjustment in behavior. The rats are always showing a lot of suppression because they're being shocked randomly. So the behavior is very, very low to begin with, and it doesn't change because they're not learning anything new. And then our values in between, the 0.1 and 0.2, are telling us that you are slightly less likely to get shocked if you don't hear a tone than if you do hear a tone. So we do tend to see more freezing as they learn that the tone is associated with a shock, but it's not as strong as our two extremes there. But our take home here is that if our CS is telling us information about an upcoming US, if it's giving us useful information, and it's letting us know more than just random chance, like in our 0 condition here, then we're going to see a lot more learning. If our CS isn't giving us any useful information, we tend not to see a whole lot of conditioning. So it's ineffective if that CS isn't telling us anything, if the contingency is weak. So having a stronger contingency, like in this treatment, we see stronger learn. All right, our next variable to consider are the stimulus features, which are just the physical characteristics of that particular stimulus. And so the physical characteristics of a stimulus are going to affect how quickly we acquire that stimulus, or how quickly we learn about that stimulus. Just realizing that my scribbles have carried over, so let's get rid of those. Okay, now we can use the process or the technique of overshadowing to figure out which stimulus feature or which characteristic is most salient or matters the most to the organism. So for an overshadowing procedure, is basically we're going to use a compound stimulus, which we have illustrated at the bottom here. So we have both a sound and a visual stimulus, so we'd have a tone and a light, and that would be presented together as a compound audio-visual stimulus. At the beginning of training, they are neutral. So these would start off being neutral. You would have your tone and your light, and you'd present food. And so the food is our unconditioned stimulus, and then our response is salivation. So the unconditioned response is to salivate. By training this up so that our compound stimulus becomes our CS, our conditioned stimulus, we still have our unconditioned stimulus and our unconditioned response. We can then test and say, okay, which portion or which feature of that compound stimulus was actually learned about. So we can test just the tone or just the light and see which one gives us a conditioned response. If both give us a conditioned response, if both have that drooling or salivation, then maybe we learn something about both of them. If only one gives a conditioned response, like the example here, we're seeing that our tone yields a conditioned response, but the light doesn't. And in this situation, we would say that the tone overshadowed the light. So we didn't learn anything about the light because there's no conditioned response. There was no learning that happened to the light because the tone was much more salient because it meant more to the organism. So with this overshadowing technique, the tone overshadowed the light. The tone was more salient than the light, and the tone is what we learned about. We didn't learn anything about the light. This process of overshadowing is influenced by the intensity of the stimulus. Generally speaking, a more intense stimulus is going to overshadow a less intense stimulus. So if the tone is really, really loud and the light is very dim, then the tone is going to matter more. But even if you have two sounds, the louder sound is what you're going to learn more about because it's more salient, because it's more intense. Overshadowing can also be influenced by the nature of that unconditioned stimulus and how it relates to the species. So there are certain features that are just a lot more easy to associate. So if you have a conditioned stimulus that's a smell, it's a lot easier to associate that smell with an unconditioned stimulus that produces sickness. So if your conditioned response is illness, you're going to learn more about an odor than you would, say, a light. And that's because in nature, something that you smell or taste is a lot more likely to be associated with something that makes you sick, because food that makes you sick might smell bad or taste bad. So the nature of the stimuli is also going to influence what you pay more attention to or what you are set up to learn. And that brings us to the next point, which is an idea of a continuum of preparedness, where we have genetic predispositions that allow us to learn certain associations more readily than others. Just like we talked about acquiring taste aversions, that's something that we are genetically predisposed to do. We are prepared to acquire taste aversions, and that's why if you eat something that makes you sick, you'll, even if you just do it once, you'll then not want to eat that thing anymore in the future because you've acquired that aversion even after a single trial. So there's lots and lots of stuff that we are more prepared to learn about, and those things will obviously give us stronger and faster learning because of that predisposition. Another thing that we have to consider is that we might have prior experience with either the CS or the US. Now, the textbook just talks about general prior experience. I'm going to touch very, very briefly on a couple of these points because they might come up again later. But we can see things like latent inhibition, where if you are pre-exposed to a stimulus that we want to become a conditioned stimulus in the future, and if in that pre-exposure it is not paired with our unconditioned stimulus, it's actually harder for it to become a conditioned stimulus in the future because we've already had experience with it where it doesn't have an association with our unconditioned stimulus. So that pre-exposure can kind of mess with our ability to acquire an association. We can also encounter blocking, where a particular stimulus can't become a conditioned stimulus when it's part of a compound stimulus, like what we just saw with that tone and the light. So if that compound stimulus already has a component or a feature that already explains or works with or works as, I guess, a conditioned stimulus, we're not really learning anything new about that other stimulus. And so we're not going to see it become a conditioned stimulus. That's something that we need a visual on. Actually, let's scroll back here and we'll just use this same diagram here. So let's say that we start with this idea that you already have a conditioned response to a conditioned stimulus of a tone. So you already know that a tone is associated with food, and so that tone is a conditioned stimulus, and hearing that tone, you produce a conditioned response. If we then go back and have a compound stimulus that's a tone and a light, you're not really going to learn anything new about the light because the tone on its own already tells you that it's associated with our unconditioned stimulus. So adding light in doesn't give us any extra information, so you don't have to learn anything else. So we would see no learning to our light. Our light would remain a neutral stimulus, and we'd have a lot of trouble making it a conditioned stimulus because it's not telling us any extra information. That's basically how blocking works. It's effectively reversed overshadowing. Just because the words on the page aren't super clear on that one. And then our third prior experience that we might have is sensory preconditioning. If we have two neutral stimuli before we go through any conditioning, and these two stimuli are already associated with one another, if we have a tone and a light, and whenever you see the tone, you also see the light, but they don't mean anything. They just mean, or they're always seen together. If we have that situation before we start conditioning, if we learn something about one of those stimuli, if we then turn the light into a conditioned stimulus, then the tone tends to get dragged along and also be treated as a conditioned stimulus as well. So if we have that pre-association, anything you learn about one will also kind of automatically be applied to the other. So these are three different ways that prior experience can influence whether you do or don't learn something about another stimulus. Basically, it determines whether or not something can become a conditioned stimulus or not. Our next factor to consider is amount of exposure to our contingencies, which is basically how many trials have you experienced or what number of pairings have you seen. And the general rule of thumb here that you might logically already have figured out is that more exposure means that you're going to have more learning or greater conditional responding. As you pair your conditioned stimulus and your unconditioned stimulus more and more and more times, your conditioned response is going to become stronger and stronger because you're learning more and more. So our early exposure is going to produce sort of a more quick acquisition of information because we see sort of this non-linear association. So if we look at this little graph over in the corner, the units don't really matter, but what we have is our strength of our conditioned response and time. And at the beginning, we'll go from sort of no responding to quite a bit of responding and have a very rapid rise, but it's exponential and it'll sort of slowly peter out. It'll slowly taper down, where after a while we stop learning anything else. We've acquired that association. There's nothing new to learn. So our responding kind of levels out. And the sort of steepness of this curve or the shape of this curve can differ dramatically based on what kind of stimuli we're looking at or what kind of association we're looking at. So like I said, taste aversions can happen after just a single exposure. Things like salivation can take many, many, many exposures. So some can be very, very quick. Some can take hundreds of trials, and it'll all depend on all of those other contingencies that we're talking about. All right, we should also keep in mind our intertrial interval, which is basically how long does it take to go from one trial to the next trial. So each trial would be one pairing of the conditioned stimulus and unconditioned stimulus. So if the trials happen very, very close together, you might see very fast learning because they're being exposed to a lot of those stimuli very, very quickly. So some of these intertrial intervals can be seconds. They can sometimes be as far apart as years, depending on how often you encounter them together. And interestingly, because we've just talked about how amount of exposure is beneficial for learning. So the more you're exposed, the better it is. If you account for the fact that shorter intervals tend to also give you more exposure in a unit time, if you account for that aspect of it, you're actually better off with longer intervals to see a more lasting association. So again, let me grab my pen here. So if we have 10 exposures, and we have 3 different options. You can have 10 trials and they're spaced out over 1 minute. And so in your 1 minute, you're going to get 10 trials right off the bat. So this is sort of 1 minute. Okay, that's fine. But what if instead we spread it out over 1 hour? And so every couple of minutes, you get 1 trial. So you're still going to get 10 exposures. I'm not counting lines, but you get 10 exposures, but it would be spread much more out. And what if you did it over, instead of 1 hour, what if you did it over a day? We would see that the acquisition would be a lot better for the one that was spread out over a day, because they all had the same amount of exposure. They all had the same number of trials, amount of exposure here, but the intertrial interval was longer, so they would hold on to that information much longer and they'd learn a lot more to begin with. And our last thing of variables affecting our respondent conditioning, we should also take into account age. So as we get older, we mature, we change, our brains work differently. We should also take into account some of the effects of health and aging. So learning and how we condition different responses and how we learn about those responses will change based on what stage of our lives we're at. Also, learning history can also influence that. As we are older, we have more experience, we have more prior exposure to things, and that changes how we learn new things as well. So it's always a good idea to keep in mind the age and the relative history of whatever organism you're looking at. And then our last slide is just a very, very brief conversation about conditioned emotional responses. And I bring this up because one of the traditional examples of classical conditioning in action falls under the category of conditioned emotional responses. And of course, this is the Little Albert study. So conditioned emotional responses are basically an emotional response to a stimulus that has been acquired through respondent conditioning. Now, most of the examples that you'll see will be fear, just because it is very easy to condition a fear response, but conditioned emotional responses can actually be positive or negative. You can see them done for happy feelings. So you could become conditioned to feel happy whenever you, I don't know, hear a song that makes you think of a person you like, or something like that. But the standard example is fear conditioning. And just a quick refresher of the Little Albert study, in case you've forgotten. You can also take a look at YouTube videos for this as well. But basically they had a small child, less than a year old, who started off where they were exposed to a white lab rat, and that lab rat was originally a neutral stimulus because Albert didn't really care about the rat. It wasn't scary, it wasn't bad, it was just a rat. During conditioning, though, the exposure to that rat was paired with a loud and scary sound. So our unconditioned stimulus was a hammer slamming on metal, something that could startle him and make him afraid. And so after multiple pairings of that rat with that loud, scary sound, Albert came to experience fear just from seeing the rat. And usually you'll see this carried over into things like stimulus generalization, because little Albert then became afraid of anything that was white and fuzzy, not just rats. But that's, I guess, a little bit beyond the point of this chapter here. Just a little bit of flavor to end off with for today.